Hey there, and welcome to your science news briefing. Let's get you caught up on what's happening this January 22nd, 2026.
All right, let's just jump right in. We've got some incredible stories for you today, covering everything from breakthroughs deep inside the human body to the fundamental laws of physics, and then all the way out into orbit. Okay, first up, we're going to look inward. We've got three huge developments in medicine that could, seriously, completely change how we predict the future of our own health. So imagine this. What if you could know you were going to get sick years before you ever felt a single symptom? Well, a new study from Sinai Health suggests that's actually possible, and they're starting with the chronic inflammatory disorder Crohn's disease. So, what they found is a new blood test. It can spot an unusual immune response to gut bacteria, specifically a protein called flagellin. It's basically the little tail that helps bacteria swim around. Now, the amazing part is that finding this so early suggests the immune response might actually trigger the disease, not just be a result of it. That's a total game changer. And get this, the timeline here is absolutely crucial. On average, this blood marker shows up 2.5 years before a clinical diagnosis. That gives doctors and researchers this huge window of opportunity to step in and maybe even prevent the disease before any lasting damage can happen. All right, moving from predicting disease to predicting, evolution itself, researchers at Moffitt Cancer Center have developed this new tool. It's called AlphaK, and it's designed to predict how cancer evolves. It's like having a crystal ball for a tumor's next move. So here's how it works. The tool focuses on something called chromosomal instability. This is when cancer cells get really messy during division and just gain or lose whole chromosomes. Think about that. It's not changing one gene, it's changing thousands of genes all at once. For the tumor, this is like a superpower. It lets it adapt and become resistant to treatment incredibly fast. And this is the really cool part. AlphaK can figure out the exact moment when doubling its entire genome becomes an advantage for the tumor, a way to survive all that instability. Being able to predict that dangerous transition point, it lays the groundwork for what they're calling evolution-aware therapy. The goal is to always be one step ahead of the cancer. Okay, so we've talked about how cells evolve. Now let's talk about how they repair themselves. There's a fascinating study out of Johns Hopkins Medicine that's flipping a long-held belief on its head. We used to think the brain only repairs its myelin coating, that fatty insulation around nerve cells, sort of as needed after an injury. Well, it turns out our brains are way more proactive than we gave them credit for. These special progenitor cells are constantly trying to make new myelin-producing cells. And this is happening all over the adult brain, even in totally healthy spots. So what this really means, especially for diseases like MS, is that the problem isn't getting the repair process started. The real challenge is making sure those new cells, which are already being made, can survive and actually do their job. All right, let's zoom way out now. We're going from the human body to the fundamental laws that govern the entire universe. And it looks like some of those old rules are actually being rewritten as we speak. So for 200 years, a rule called the Carnot principle has basically set the speed limit for engine efficiency. It was considered a fundamental law. But researchers at the University of Stuttgart have just found a loophole. It turns out that in the super weird world of quantum mechanics, you can actually break that law. Okay, let me break this down for you. In our big, everyday world, an engine's efficiency is limited by the temperature difference it works with. Simple as that. But when you get down to the atomic scale, you can tap into a whole new energy source, the energy that's literally stored in the connections between particles. It's called quantum correlation. And you can convert that energy into extra work. What that means is future nanomachines could just blow right past the efficiency limits we thought were set in stone. Now for some real-life time travel. Scientists have basically resurrected a 3.2 billion-year-old enzyme called nitrogenase. I mean, how cool is that? This little enzyme was absolutely essential for life on a very young, oxygen-poor Earth. It's the thing that takes nitrogen from the air and turns it into something life can actually use. And here's why this is such a big deal. By studying this ancient resurrected enzyme, scientists confirmed it leaves the exact same chemical fingerprint, or biosignature, as the modern version does today. For anyone searching for life on other planets, this is huge. It gives them a much more reliable signal to look for out there in the cosmos. And finally, let's turn our eyes to the skies, because it has been a very busy 24 hours in space. Rocket Lab successfully launched its first mission of 2026. The mission, which had the pretty cool name The Cosmos Will See You Now, took off from New Zealand. It deployed 2 satellites for the European company Open Cosmos, and this also marks Rocket Lab's 80th launch.
Pretty impressive. Meanwhile, over in California, SpaceX was busy too. They launched their 9th mission of the year, sending 25 more Starlink satellites into orbit. And just think about that for a second. This is their 9th launch in 2026, and it's still only January. They are just flying.
With this latest launch, the total number of active Starlink satellites in orbit is now pushing 9,500. That is just a staggering number, and it's helping expand internet access to some of the most remote places on the planet. And that wraps up our science news briefing for today. Hey, thanks so much for tuning in. If you want to stay on top of all the latest discoveries, make sure you like and subscribe. We'll be back with more daily updates.